Okay, so let's try this question. This is basically the whole chapter. I've just got questions for the whole chapter because it can be taught in one go. So section 1 is this, section 2 is this is section 3, and this is the last section. Alright, so let's start with section 1. So this diagram over here shows the region R, which is bounded by the x-axis, the y-axis, and the curve y is equal to 9 minus x squared. The region is rotated through 2 pi radians about the x-axis. So we are rotating this, like this, and then it's going to be this sort of solid created. Find the exact volume of this solid generated. Well, we know, I should just write this in black, we know that the formula is pi times the integral between x1 and x2 of y squared dx, or pi times the integral between y1 and y2 of x squared dy. Alright, so for this question, we're rotating about the x-axis, so we're going to be integrating with respect to x. Because our two bounds are 0 and this, we're going to have to find what this is. Well, this is just the x-intercept. So for x-intercepts, y is equal to 0. So for the x-intercept, we're going to set 0 is equal to 9 minus x squared. So x squared is equal to 9, and x is equal to plus or minus 3. Well, it's clearly not minus 3 because this is 0, this is going this way, so it's going to be positive 3. X is equal to 3. So now all we do is we just do our volume of revolution formula. So therefore the volume is going to be given by pi times the integral from 0 to 3 of y squared. Well, y is this, so y squared is just going to be 9 minus x squared all squared with respect to x. Sorry, that's a loud noise outside. Okay, so now we just take that's pi times the integral from 0 to 3 of 81 minus 18x squared plus x to the power of 4 dx. Yeah, that looks right. Now we just integrate. So this becomes pi lots of 81x minus 6x cubed plus x to the power of 5 over 5 between 0 and 3. Now we substitute our bounds in, so we get pi lots of 81 times 3, which is 243, minus 6 lots of 27, which is minus 162, plus 243 over 5. And then we're minusing, that becomes 0, that becomes 0, that becomes 0, so just minusing 0. Well, now you just simplify this, and this gives us 648 over 5 pi. And I guess units cubed, if you wanted, because it's a volume. So our answer is 648 over 5 pi. And that is what they got as well. Alright, so that was the volume of revolution about the x-axis. Now we're going to do it about the y-axis. So that's our function, y is equal to the square root of x minus 1. The region R is bounded between the curve, the y-axis, and the lines y equals 3 and y equals 1. So we are rotating this about the y-axis, so it's going to be extended like here, I guess, and then we'll get this, so this sort of solid, I guess, like that. Find its volume, easy enough. We don't even have to find the bounds this time because we're already given them. So this is just pi times the integral from y1, which is 1, to 3, of now x squared dy. Well, x squared we need to find. Well, y is equal to the square root of x minus 1. So y squared is going to be equal to x minus 1. X is going to be y squared plus 1. So x squared is going to be y squared plus 1 all squared. So this becomes y squared plus 1 squared dy now. Okay, that's just pi lots of integral from 1 to 3 of y to the power of 4 plus 2y squared plus 1 dy. which we can change pi lots of y to the power 5 over 5 plus 2 thirds y cubed plus y between 1 and 3, which is pi lots of 2 4 3 over 5 plus 18 plus 3, and then minus a fifth plus 2 thirds plus 1, which when you simplify all that becomes 1016 over 15 pi, and if you want you put units cubed. So that is the answer, and they agree with us. 1016 over 15 pi. That's the working, same as us. Alright, so this is section 1 and 2. Now section 3 is when you've got a kind of composite area, so it's bounded between two functions. Like that. Well, all you do is really, you just add or subtract them. Usually it's always subtract. So to find this area, if you split it over here, you're going to find this area underneath the curve, and then this area underneath the line. So you'll have to find this point of intersection. So, oh, but you already told what this point is, 1, 3, so part A is to verify that. So verify that the coordinates of A is 1, 3. So, all we do is we plug it into the curve. So the curve, if we plug in x equals 1, we're going to get 1 cubed plus 2, which is equal to 3. Therefore, 1, 3 lies on curve. For the line, y is equal to 5 minus 2x. 5 minus 2 lots of 1 is also 3. Therefore, 1, 3 lies on line. Therefore, point A intersection is 1, 3. Okay, so that's verified that point A is the coordinates 1, 3. Now part B, we have to find the volume of this solid. Well, we're going to have to do two separate integrals here, because for the first one we're going to be integrating the curve between 0 and this is x equals 1. And then for the second one we're going to have to integrate the line, or just find the area of the triangle, this is a right angle triangle, between 1 and this x-intercept. So we're going to first have to find the x-intercept of this. So part B, we're going to find the x-intercept of the line by setting y equal to 0, so you get 0 is equal to 5 minus 2x, so you get x is equal to 5 over 2. Alright, so now we can integrate, so therefore volume will be given by pi times the integral. Now this is the first one is between, this is this, so between 0 and 1 at first, 0 and 1 of the function, so x cubed plus 2, and that's squared, and then dx, and then we are adding it to the integral, pi times the integral of, this is between 1 and 5 over 2, of the line which is 5 minus 2x, and we're squaring that dx, because of y squared dx. Now we just compute these integrals, so pi, lots of the integral from 0 to 1, of x to the power of 6, added to 4x cubed, added to 4 dx, added to pi, lots of the integral from 1 to 5 over 2, of 25 minus 20x plus 4x squared dx. Alright, now this equals pi lots of x to 7 over 7, added to x power 4, added to 4x, between 0 and 1, added to pi lots of 25x minus 10x squared plus 4 thirds x cubed. That's to 1, 5 over 2. Yeah, I'm computing these, so we get pi lots of a seventh plus 1 plus 4 minus 0, added to pi lots of, 125 over 2 minus, not really 125 over 2, added to 125 over 6, subtract 25 minus 10 plus 4 over 3. This first one becomes 36 over 7 pi, and then we add it to 92 pi, which gives a total area of 135 over 14 pi units cubed. That's the area, meant volume. Alright, so if we check the answer now, So part A they verified like we did, and then part B they did the same thing, so they split it into R1 and R2. They found this is 2.5, this is 1, calculated this interval for 36 pi by 7, which we got, and then here they just did the volume of a cone. Oh, did I said area of the triangle? I meant volume of a cone, because that's going to be like this, so it's going to be a cone, so you're just going to have to use 4/3 pi r cubed. No, a third pi r squared height, my bad. And then that gives you 9 pi by 2, but we also got 9 pi by 2 just by integrating. So yeah, 135 pi by 14, 135 pi by 14. Very nice. Okay, so now for this question here, we've got a region R over here, bounded between y equals root x and y equals 1 over 8x. Okay, so first we're going to have to work out how is this area created. So it's going to be probably this one minus this one. What we can do is find this point of intersection, and we're going to integrate from here to here. So this will give us like all of this area, and then we're just going to subtract, yeah, all of this. So it'll give us this right here. So the first step is to calculate the point of intersection. So intersection. Well, this is going to be when root x is equal to 1 over 8x. So 8x root x, oops, is equal to 1. This is an indice, that's going to be 8x to the 1 plus a half, 3 over 2 equals 1. So x to 3 over 2 equals an eighth. So x is going to be an eighth to 3 over 2, which is no, to 2 over 3, my bad. 1 over 4. So this intersection here is going to be a quarter. Okay. So now, like I said, we're going to integrate from a quarter to 1 to find all of this area, and then we're going to subtract this from a quarter to 1. So it's going to be same bounds, so we can actually just combine it into one integral. So therefore the volume is going to be pi lots of the integral from a quarter to 1 of the top curve, which is root x. Well, it's going to be y squared, so it's going to be x. And then we're minusing the 1 over 8x, so that's just square, so it's going to be 1 over 64x squared dx. We can just go ahead, this is easy enough to integrate, so that's just pi lots of a half x squared minus, this is 1 over 64x to the minus 2. So you integrate that, the 1 over 64 is going to stay, and then minus 1, so it's going to be plus this from a quarter to 1. Yeah. Okay. So now this is just pi lots of a half plus 1 over 64 minus a half times a 16th. 1 over 32 minus 1 over 64 times 4 minus 16th, which will give us 27 over 64 pi units cubed. So that should be the answer. 27 over 64 pi. Yes, it is. So they found the intersection as a quarter, and then they did R1 minus R2. They did it separately. You could have just done it under the same interval because the bounds were the same. Both were between a quarter and 1. So you could have just combined it into one interval. Alright, so now we're on to the last section, which is modelling, where you just got a big chunk of text, but everything is the exact same. Alright, so a manufacturer wants to cast a prototype for a new design for a pen barrel out of solid resin. The shaded region shown in the diagram is used as a model for the cross-section of the pen barrel. The region is bounded by the x-axis, the curve with equation y equals k minus 100x squared, and will be rotated around the y-axis. Each unit on the coordinate axes represents 1 centimeter. So you see we've got this like scale here, it's like modelling in a real life thing now. So basically this region will be rotated about the y-axis, so that will like become 3D, it'll be like this. So yeah, so you'll get like there's a pen barrel, so this is like the body of like your pen, like looking like this, like 3D. And part A, we have to suggest a suitable value for k. So part A. Well, k is going to be this point up here. This is k, because it's your maximum point. It says suggest a suitable value. Suggest, so you're going to have to, I guess, like give something sensible. Well, if it's basically the maximum height, it's like the length of the pen barrel. So if you look at a pen, like I've got a pen right next to me, that's what, about 10 centimeters, roughly. So I'd put k equals 10, because each unit is a centimeter, so just 10 centimeters. So yeah, it should be 10, around 10-ish maybe. Okay, so part B. Use your value of k to estimate the volume of resin needed to make the prototype. Alright, well, since we are integrating and finding the volume, we're rotating about the y-axis, we're going to have to use pi times the integral of x squared dy. So first we need x squared. Well, that's just easy enough. If we rearrange, so we've got y is equal to 10 minus 100x squared. So 100x squared is going to be 10 minus y. So x squared is going to be 1/10 minus 100th y. So our volume is going to be pi, lots of the integral. Now this is between 0 and 10, remember, of 1/10 minus 100th of y dy, which is easy enough to calculate. That's just pi lots of the integral over 10x minus 1/200 y squared between 0 and 10. Well, that's just pi lots of 1 minus half, and then minus 0. Well, that is just a half of pi, which is pi by 2. So pi by 2 units cubed, or centimeters cubed, because each unit is a centimeter. So pi by 2 centimeters cubed. Okay. And then part C is state one limitation of the model. So I'm going to put that the cross section of the pen is unlikely to be modelled by the curve exactly. Okay, now if we look at the answer over here, so yep, they've chosen k is equal to 10, and the reason they've given is consider the context of the question and choose a value that makes sense. Most pens are between 10 and 15 centimeters long, so any value in the range k is between 10 and 15 inclusive is sensible. So you could have put 10, 15, any value between that. They also got the volume using 10 as pi by 2, which is what we got, and then the cross section of the pen is unlikely to match the curve exactly. Ooh, my bad. 3 significant figures, it's modelling. That's approximately 1.57 centimeters cubed. I got that wrong by accident. Yeah. So always give your answer to 3 significant figures and with units. Actually, in pure, I don't think it matters too much. It's just mainly in applied, you have to give it a 3SF. Here, pi by 2 centimeters cubed might hopefully be accepted. But yeah, so I hope this was helpful. Modelling, it's just going to be the same thing. You just have to be able to apply it to real life. But yeah, I hope this was helpful. This is the end of the